Hey everyone, this video is on relativity, Einstein's groundbreaking theory that changed the way scientists view the universe. Starting back in 1906 when he published his first paper on theory of special relativity, today specifically we are going to talk about the small aspect. Our topic today is going to be time dilation. So first of all, the definition of relativity. The theory of relativity could be simply explained just by saying that all the laws in the universe are the same, are valid in all parts of the universe. Laws of physics, and specifically the speed of light, are the same from all perspectives to all observers. It doesn't matter where in the universe you are or how fast you're moving. Laws of physics and the speed of light are always the same. So time dilation is a strange result of that theory, as a consequence of making the speed of light universal. It's always exactly the same no matter how fast you're moving wherever you are in the universe. Well, something else has to change. We end up running into small problems that don't make any sense, unless time is flexible, and Einstein is the first one to come up with this explanation, that therefore, if the speed of light is always the same, time can be different in different situations. So, some cases time stretches out and slows down. In some cases, time speeds up. So that's basically what time dilation is. Now let's talk about an example. We believe that if you move really fast, let's say half the speed of light, that time for you slows down relative to somebody slower or maybe someone who is at rest. So the reality of someone moving faster is different, and in that reality, time moves slower. The classic example of this is called the twin paradox. So there are twins born that live together. Their whole childhood they looked identical, and one becomes an astronaut before getting onto a rocket taking off into space. The two siblings hug, say goodbye, and then the astronaut gets on the rocket, takes off, and travels for a few years, and he travels 10% the speed of light, something incredibly fast compared to the velocity happening here on Earth. And after a few years, the rocket returns. The astronaut gets out, the sibling is waiting there, and they embrace after not seeing for years. And then they notice the person who was in the spaceship was younger than the person who stayed on Earth. In fact, while moving really fast compared to the speed of light, the twin who was an astronaut aged less because of the time slowed down, and the person who is on Earth experienced time happening faster. So the person had more years, more birthdays, and when they were reunited, the person stayed behind on Earth was older. So that's a twin paradox. Is that possible? Is it like time travel? What's going on? Well, to explain this, now let's look more specifically at the concept of time dilation. So the theory of relativity states that all the laws of physics, including the speed of light, are the same from all perspectives, in all reference frames. What that means is if you were in a car traveling half the speed of light and you turned on your headlights, you would measure the light leaving your headlights and traveling away from you, and you would get a number that's exactly the speed of light. Whereas if you were driving a car at the speed of light and you passed somebody on the side of the road, the person stationary would watch the light coming out of your headlights, measure it, and see the light coming out of your headlights is exactly the speed of light. Now that may not sound too strange, but if we were talking about somebody driving down the road in a car and throwing a baseball. Car is going 50 miles an hour and you throw a baseball that's going 20 miles an hour. To them, it leaves and goes forward ahead of the car 20 miles an hour. But to the person on the road, the baseball is going 70 miles an hour. So you would have to add the two velocities. The car is going 50 miles an hour, plus you threw the baseball forward at another 20 miles an hour. And when you add the time, you get 70 miles an hour. So if the person on the side of the road tried to catch it, then it would hit them at 70 miles an hour. But the speed of light is different. The person traveling in the car thinks that they're going half the speed of light. They turn on their headlights and they measure them at the light leaving the headlight is going exactly the speed of light. Yet the person on the side of the road would measure the light coming out of the headlights as traveling at the speed of light at the same number. So one way to understand this and to realize why we have to have time dilation for this to work is to talk about a light clock. So what we are going to talk about now is an example where we're going to compare two different frames of reference, one at rest and one moving. And the device we are going to use to measure time is going to be a clock, a strange kind of clock. It's going to be a simple box of a light source. It's going to have a mirror. You turn on the light clock, the light at the bottom leaves, travels up to the top, hits the mirror, bounces off it, travels back down to the light source, and that's how we're going to keep time. So if you were still and the light clock was on your lap, you would just see the light leave the light source, go up and bounce back. And that would take a certain amount of time. Now let's say somebody else was traveling on a rocket moving really fast with that same light clock on their lap. It takes the same amount of time for the light clock's light to go up and bounce back. Let's say your friend was sitting by a window in a rocket and you were watching them travel past by you from Earth. He's going at 10% the speed of light. You would see the light from the light clock go up when he was at this point. But when it bounces back to the light source, he would be at this point because he's traveling at 10% the speed of light. The light would leave and arrive at the bottom at the same time. The main point is that the distance the light travels seems to change. The moving clock in the window seems to have the light moving at a diagonal, a hypotenuse of a right triangle. This longer distance is traveled in the same exact time as it takes the light to go over the smaller distance in the stationary light clock, the one at rest. So they travel two different distances, and they do it at the same exact time. And they're both traveling at the same exact speed, the speed of light. How can they travel different distances in the same time interval if they are both traveling the same speed? Something has to be different. But what? The answer is time. The story about the light clock is helpful because it illustrates the reason Einstein and other scientists believe that time is relative to where you are and how fast you move. Okay, so the example of the light clock is weird, but it's just to show how simple the laws in the universe are, including the speed of light, are the same everywhere from all perspectives. Now, what you need to know is it isn't just that the clocks are broken, but time itself actually slows down. There is a way to remember this. If you read about relativity, you will read this phrase, moving clocks run slower. And that's true of the twin paradox. When one sibling left and the other stayed on Earth, the one who was moving faster, time progressed at a slower rate. So his cells aged at a slower rate, things fell at a slower rate, gravitation, acceleration, everything was consistent, but the time reality was actually different than the reality that they were comparing to back on Earth. And similarly, with the light clock example, the person with the light clock standing on Earth we said was at rest, but the time on the rocket moved slower. But it doesn't mean that the clock was broken, but since it was moving at 10% the speed of light, time slowed down for him. So moving clocks run slower is a nice way to remember it, but it isn't the clocks that are different. It's all of reality. Time itself is different in those situations. And that is the theory of time dilation.